Good afternoon. Well, I guess it's afternoon. It is for me. This is Ralph Brandt from the Fireside. Over the last couple of years, I've been doing some fun things, restoring some 1930s, 40s, and 50s electronic equipment. Now, this stuff has those glass things called tubes, and they get kind of interesting. I'm going to talk a little bit about that and how I approach doing it, and I may be able to stick some pictures in here to show some of that work. When I take another radio or another piece of equipment, in most cases it's radios, although I have done a tube tester, which provided me with some nice test equipment to work with, and I've done a signal generator and a capacitor resistor tester also. Just for fun, because quite frankly they don't have a whole lot of utility. When I pick up a piece of equipment, the first thing I look for is to see if somebody else has been fiddling with it. Now, you'll laugh at that in a sense, but let me explain something to you. If someone else has been fiddling with it, you really don't know what they've done. This is true in any kind of troubleshooting, which restoration is a troubleshooting exercise. If somebody else has done something that causes a problem, you don't know if it was the original problem or a new one. I can remember Mr. Carlson, who does a really good videos on electronics, pulling out a Yaesu FT1000, I believe it was, and finding out that somebody had really worked on it and had actually taken things apart and left them apart. And quite frankly, in watching this hour and a half or so video, they had done more damage than what originally was there. The original problem, if diagnosed, would have been found to be a 75-cent voltage regulator. But he actually had probably 10, maybe 12 hours of work fixing the things that they created while troubleshooting. So one of the first things I look at is to see if somebody's been fiddling. A earmark of that is tubes have been pulled out and put back in the wrong sockets. One of the things that you never want to do if you're going to restore a piece of electronic equipment, don't turn it on. Period. We'll talk a little more about that later, but the answer is do not plug it in and turn it on. I guarantee you there's a 90% chance you will do more damage, and that percentage may be even higher. If you do find out evidence that somebody else has been fiddling with it, you might want to just set it aside, and I'll wait until I want something to work with that's frustrating. Second thing that I do is front, back, side, every angle, I photograph it. And I may start videoing some of that. I do it from all directions. And I do this before I take it out of the case. If there's a back, I take the back off, and then I photograph what's there. I stage the photographs so that I can see what everything was like. I don't clean anything up until I'm done photographing. The next thing I'll do is try to get the radio out of the chassis, or the chassis out of the cabinet. And at that point, more photographs. Again, before I start cleaning it up. If there's a tube layout inside, I photograph it up close. If I pull the tubes, I look at each one. Does it have a designation, a number? Those numbers will be on the older stuff, like 39, 80, and on the newer 12AT7, 50C5, 35W4. But make sure that you pick up every tube number. If it is not on the tube number clearly, put a tag on it. If it has a Bakelite bottom, I will usually use a embossed tag and put it on the bottom, because that's not going to get hot enough for it to peel off. Sometimes the tube sockets, if you look straight down in them, on the older tubes, the 4, 5, 6, 7, 8 large pins, these pins are quite large, those, quite frequently, the socket will actually have the tube number on it. If that's the case, I take a picture straight down that's good enough to see the numbers. I document everything as much as possible. Careful with tubes. The little miniatures that are about 3/4 of an inch in diameter, careful with pulling them out. Pull them as straight as you can. Wiggle them a little bit, but bring them out. And be very careful when you put them back in, because if you bend one of those pins badly, you can have a long time trying to straighten them, and you can actually break one of them off. Those are only about equivalent to a maybe number 16 wire, maybe 14. The larger pins are sort of about the size of the pin, the ground pin on a regular AC cord. There's also something called octals and loctals. Octals are a tube that have 8 pins, so does a loctal, by the way, but they also have a center locator. How do you tell the difference? The center locator on an octal will be Bakelite, a black plastic. The loctal, it will be metal. And if you look at it carefully, the loctal will lock in. If you try to pull a loctal out straight up, and by the way, the octals you want to do that with, again, with a little bit of juggling. But the loctals, if you try to pull them straight up, you'll either damage the socket or the tube, or just not get it out, because they are designed to lock in. Now, if you look at the bottom of the loctal, you'll see a little keyway. The way you remove a loctal is to lean the tube towards the keyway and then pull. That releases the lock. We'll talk a little more about loctals, but one comment I'll make, a lot of the loctals are on Philco equipment. If there's no number on the tube, can't find anything, put a tag on it with the likely number based on the tube chart. If you don't have a chart and you don't have a number, you're flying blind. There is a way out on that. There are websites that have many diagrams of radios. They are typically schematic diagrams, not pictorials. So therefore, what you will have to do is look at the schematic and figure out, oh, that end is the antenna, that end is the power output for the audio, and then you start counting tubes across. They'll be in the same sequence. Like I said, if there's no number and you have a likely number, put that on. I typically will put a question mark behind the number so that I know this may or may not be. I've seen tubes swapped where someone pulled one tube, pulled 2 tubes, and switched them. Of course, now you've got to decide whether you believe the way they were or the way they should have been. And I'll take the way they should have been. My next thing is to check if I have all the tubes. If you're missing a tube, you need to then find out if you can find one. I have a tube tester. So at that point, I will roll up the tube tester chart and test each one. I do not throw out a tube unless it is just dead. If it will not light, it needs to go out. Unless you want to keep it as a thing to put on the mantle or something. I don't. I got plenty of tubes. Second thing is, if you do not have a tube tester, pull up a chart or a specification for that tube. You go out on the web and search tube 6L6, let's say, specifications. You will come up with a chart that will show the tube, the circle, with the elements inside. One of those elements will be a little V that will go 2 ways and connect to 2 pins. That's the heater. That thing, if you test it with an ohm meter, has to have a resistance probably less than 100 ohms. I haven't measured one lately. If it is open, it has no continuity, the tube is no good. It won't light. Then the next thing is to take each pin with the ohm meter and then work around and make sure no two elements other than the two filament connections are shorted together. Shorted tube is no good. If you have nothing but an ohm meter or a multimeter, that is a valid test of a tube. Not valid in knowing whether for sure it's good or bad, but if it fails one of those tests, it's bad. I see if I can get replacements if I have missing ones or bad ones. Now I have 3 or 4 large boxes of tubes, so I have a pretty good stock of miniatures, octals, some of the older stuff. I'll tell you a funny story about that. I needed a number 39, and I was at a ham fest. And I saw a guy who had tubes there, and I went over and I went through his box. They'll let you do that usually, looking for a 39, and I found 2 of them. And I said, how much? And he said $20. That's 10 apiece. I looked at him and said, how much for the whole box? He said $30. I picked up the box, gave him $30, and walked away and left the 2 number 39s laying next to the box. I left without the number 39s. I've never said that I was the brightest bulb in the string. Remember, when you're working with these radios, there are voltages there that can kill you. Just good old 110 coming in can do you in if it hits you right. Keep that in mind. Use the right hand when it is powered on, left hand in the pocket. I am alive because of that. I hit a 600 volt DC plate cap on a 6146 transmitter tube. I went down, but I came back up. Yes, that's called stupidus rex. My next thing is to kind of clean the thing up, clean as much dirt, crud, crap out of it, because most of these have been stored somewhere that wasn't the best. Now, there are 2 elements in those radios that are old enough and have deteriorated enough. In 30 years, they've deteriorated enough that it's called replace them. Now, I know there are some restorers who say, oh no, they'll try them. Well, every one of them I've tested has been bad, and I've tested probably 50 or 60. At this point, I don't bother. I replace the filter capacitors. Rule on filter capacitor. Number 1, if it says 50 volts, you can put one in with a rating of 150 volts or 400 volts if you can't find one that's 50, but you can't put a 35 in. It must be the rated voltage or higher. That's number 1. Number 2, many times you are not going to be able to find the actual capacity, called microfarads, MFD, whatever. You're not going to be able to find one that's right. I have a slew of radios here, or a radio here, that has a slew of 8 microfarads. I think there's 4 or 6 of them. 8 microfarads, and I couldn't find any 8s. Well, if you take a look and think back, when these radios were built, the electrolytic capacitors had a tolerance of 20%. Most of the electrolytics I'm buying right now have a tolerance that's less than that. I start looking at that and I say, if I have an 8, and by the way, I may have 8 and 10 backwards because I did this some time ago. If I have an 8, 20% more is 9.6. And I'd forgotten whether it's 10s to 8s or 8s to 10s. But I've done that replacement with no problems. Many of those, I usually try to go a little higher because many of those are used simply to clamp down AC or signal level. It's a little bigger, it just clamps it down a little better. After I get done, okay, let's talk about replacing the filter capacitors. For aesthetics, I have ground out one that was in a metal can, put together a piece to go in, and replaced it that way. Be careful to insulate everything real well. Down below, somebody can find out that it wasn't done that way. The other thing that I will do is if I can, I won't take it out. I'll just disconnect it and wire the new caps in under the chassis if I have room, and you usually do. One of the things of the capacitors in the can, and occasionally ones with pigtails, there will be 2, 3, and even sometimes 4 capacitors in one. If you wind up with that, just make sure you look at the color chart. It'll say 30, 30, 20, and then you look at it, and the 30 and the 30 are, let's say, 250 volt, and the 20 is only a 50 volt capacitor. It's because these are used for filtering the high voltage, and the other one is used to tie the cathode of the power output tube, the audio out, to ground. As far as signal is concerned, it only needs to be 50 volts. Now, if you have a 20 that's 400 volts and nothing else, okay, just don't put one in with lower voltage. And that's a lot of the things that I work with, is to just simply replace all those caps. The next thing is to get rid of all the papers. Now those will look like a little thing that's little tube that has wax on it. If you can't see the number of microfarads, and that'll usually be something like 0.1, 0.01, 0.001, 0.5, those, it's in that range usually. If you can't see it, scratching the wax off with your fingernail or with a popsicle stick, something of that sort. Do not use metal. You can often get it cleaned enough to see what it is. I have some rules on looking at the schematic, and if I don't have a schematic, I look at what pin it's coming from and what it's going to, or where it's going, and then I look at what's likely to go there. I have put in what I thought was right, and I've hit it. Don't buy new papers. They were made in 1950 or before. They've been stored somewhere. They're in no better condition than the ones that are in your radio. I've gone out on Amazon and bought a box of various sizes, various ones. I always look for a 250 or 450 rating, so therefore I don't have to worry about what I'm doing, voltage rating. You may need to learn the new coding structure, and that's available. It'll be like 103K. If I remember correctly, that means 0.001. The 1 is the digit, the 3 is the number of decimal places, and the K, I think, is the voltage. I've not worked with this a whole lot, other than I just buy them, make sure they're what I want, and go with them. Just be careful replacing a 0.01 with a 0.001 or a 0.01 or 001 will cause you trouble. I buy polys, good capacitors. Do not buy disc ceramics for this. They're lovely capacitors. I use them in transmitters, but not for here. You let one bad paper capacitor in, and it happens to be shorted. Many of those will go from the plate, that's at 100 volts or better, to the grid, that's 3 to 5 minus volts, and it blocks the DC. So that 100 volts doesn't get there, but the signal goes across. Well, here's a little problem. If that capacitor has a DC short, you've now put 150 volts or so on the grid of that tube. The grid of that tube will light up, and then that tube is no good. You may also short it and blow the plate out on the other side, or something else. I make sure that I get all of those. Also, when you're doing wiring, make sure you're not introducing shorts between things. I've had one radio where the insulation on the hookup wire between points in it was rubber. And when you touch it, it would fall off. My only choice was to sit down, new hookup wire, and replace the wires one for one. I blew a tube on that one because I missed a wire. It was a Loctol. They're a little harder to find. You can do all kinds of things. I keep shrink tape because sometimes the lead from the capacitor to the wherever it's going, sometimes it needs what we used to call spaghetti tubing. It's just a wire insulation. You slide over it. I found shrink tape works shrink tubing works real good for that. Doesn't matter too much whether you shrink it or not, as long as you use something small. Usually, when you put the heat on it with the soldering iron, it'll shrink up. I bought the kits of poly capacitors. Just make sure they're high enough voltage. There is a tremendous amount of low voltage electrolytics and polys out there because they're used with transistors. Unfortunately, they're no good here. The next thing is I usually go, now I've got the bottom cleared, I go to the top. One of the things I do is get a can of air and I blow out the variable capacitor. That's the guy with the plates that go in and out of each other. I blow those out real good, making sure there's nothing in. Be careful, blow with the plates, don't bend them. Don't touch them. Don't try to clean them with something else. I don't know whether alcohol will, I've never used alcohol, but I don't see any damage with it, but I've just never had to use anything. You clean that up. I use contact cleaner on the switches and potentiometers. That's like the volume control. Usually you can get it in the side of the volume control, up where the pins are. There's a place that you can blow some in, and then do a twist. Same thing with the switches. Flip them back and forth. You want to get all corrosion off of them. Then we go to the fun thing. Hopefully, your radio, when you turn the tuning knob, the indicator, if there is one, and there usually is, moves back and forth properly, and the variable capacitor goes in and out properly. In the high end, like at 1600, for example, the plates should be the whole way out, and the indicator should be at 1600. At the low end, down around 550, the plates should be the whole way in. If that doesn't happen, you have a problem. And that's a mechanical problem. One of the things that I've found works real well is take a Q-tip with a little belt dressing that you can buy at a place like Advance Auto, one of those auto places. Take a little belt dressing, put it on a Q-tip, and wipe the dial cord. And then wipe the two pulleys that goes around. As they get older, they lose the wax that was on them, and they slip. That's fixed every one of them I've had, except the ones that the dial cord is missing. Now, there has to be a spring inside the one pulley, the one that's on the variable capacitor, or somewhere in it. It has to have a spring to keep it tight. If there's no spring, see if you can find a spring from a ballpoint pen flatten the ends, squeeze it, and see if that'll work. It has for me, may not for you. No lubrication anywhere near that dial cord. Can lube the ball bearings in the variable capacitor, but not on the dial cord. I had one with the cord missing. My grandson, KC3MDT, is doing restorations too, with some guidance. And I spent 2 hours with him to restring that thing. It just takes patience, but we got it done. Most of the radios I've been working with are the AC/DC models that do not have a power transformer. These started around 1940, and I know they went through till at least the mid to late 50s. There's actually about several models of these, but they're all pretty much the same. The schematic for them is almost identical, except there's a 6 and a 5 tube version. But other than that, and the more recent ones use the miniature tubes, not the octals and loctals. If the unit has a power transformer, it will have either an 80 rectifier tube or a rectifier tube that has a number like 5U4. The letter can be different, but it's going to be one of those. Treasure those tubes and the transformer. You blow the transformer, getting a replacement is extremely difficult, and it's costly, unless you get lucky. AC/DC models have like a 35, some letter, 4 or 5. With those, any transformer on there is the audio transformer for the speaker. Don't worry about it. On all of these, the B+, which is what it's referred to, in the old radio, it was A and B, A, B, and C, really. A was filament to heat the heaters, B was the plate voltage, and C was biases for the grid. Now, by the time these radios, the AC/DCs come out, the bias was handled by putting a resistor in the cathode of each tube so that the grid was negative. Got rid of one problem. On the older radios, and really the better ones, the B+ from the cathode of the rectifier will go to the field coil on the speaker. Usually this is in better radios before 1945. It was easier to wind a coil there and make a good electromagnet for the field coil for the speaker than it was to use a permanent magnet. You could get a higher magnetic flux. This B+ going through there energizes the field coil of the speaker in lieu of a permanent magnet. And it puts a choke, an inductor, in series with the B+, which means that if you have 2 filter capacitors and that choke in there, you have a pi filter that filters out a lot of the hum. It takes the hum out of the B+ more effectively than even larger capacitors. Some of those old radios have astonishing quiet and quality. Note I said that this was done in better radios. The next step is to replace the line cord with a 3-pin cord. I use discarded PC power cords, cut the PC end off of it, strip it back. It has 3 wires. No matter what, the green wire gets soldered somewhere to ground. Good, solid solder to ground. Usually there's a tie strip or something. At worst, I'll put it under a screw, but make sure that it's got a spade on it, that it stays under. This is to keep you from killing somebody. The white and black, if it's an AC/DC, it's going to either go to the chassis or what is called B-. You can find that by finding one of the cords will come in and go to the switch. That's the hot line. That's the one that the black goes to. Follow the other one and you put the white wire on there. White or the neutral goes where the one that does not go to the switch. Always, 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 the switch must go in the black cord. Otherwise, the radio is hot when it's turned off. I can sometimes use check the polarity from the cord, but usually the easiest is just to take a look, follow the cord to the power switch. And the power switch, by the way, in most of these will be on the back of the volume control. It's a switch that gets flipped when the volume gets turned the whole way down. Black must never go to the chassis. At this point, I'm sitting there and I think down through everything I've done and I say, okay, it's time to power this up. I personally will not power one up without a variac. That's a variable transformer that allows me to take 115 volts and with a knob take it from 0 and bring it up slowly. I have mine mounted in a box. I got a real deal on one, the variac itself, and I wound up putting it in a box with a power switch with a fuse, pilot light, and what I do is I sit there with the variac and my other finger on the power switch so that I can get it off fast if something goes wrong. When you start bringing it up that the tubes do not light, it may be the power transformer. And by the way, I bring it up slowly at about 65 volts. The tubes should light dimly. In the old days, we called this a big smoke test, and there was a reason for calling it that. But any hint of a problem, shut it off and start working. If the tubes do not light, and it's one of the ones with a power transformer, check for 6 volts. No power transformer there. It could be a ballast resistor in the heater string. That's the ones with the 50 and 35 volt tubes. They are all wired in series. If you take 50 plus 35 plus 3 times 12, you'll get very close to 120. They are connected in series. It's like the old Christmas lights. One of them burns out, they all go out. If you've checked the filaments up until then, there shouldn't be a problem with that. There may be a ballast resistor in the heater string. By the way, some of the old ones have a cord that actually has the ballast built into the cord. I've never worked with one of these, and I'm not sure I ever want to. Okay, if you have no heaters, it's time to work with an ohm meter and a diagram. And start out with the two ends. One good thing to try is just make sure that the power switch actually is good. I have actually had a power switch fail, and it clicked, but it didn't come on, and I had nothing. One way to check this is just put I have cables with 2 alligator clips. With it unplugged, put the alligator clips across the 2 connections on the power switch. That's on the back of the volume control. Plug it in, turn it on, or you can do some resistance checking, which is the other thing that I do. Now, if you get that far and you're new at this, I'd suggest you go out to this website that is working with old radios and post a question. But please get the model number of the radio and the make, because without that, we're shooting blind. Now, if you take a look behind me, I think you'll see a beige radio. That's my first baby, and it works. It's an AC/DC, octal tubes, and it's just a really nice radio. But that radio could have killed you if it was plugged in the wrong way and all that had to be done was the knob missing. Now, when you get that far, you tune around the band, you see if you can find a signal, and if you do, you're now ready to move into what I'm going to call the alignment phase. I'm not going to cover that today. If it isn't working and you can't find any signals at all, then you need to start working with what works and what doesn't. That's where it becomes fun. And that's where, if you're new at this, ask for help. There's a lot of things that you can do to make a quick check and see if it's a big problem or a little one. If you've got good tubes, it's now probably something that you've either done wrong or something that maybe somebody else fiddled with before you got to it. All I'm going to say is best of luck to you. And remember, this is not the ultimate on restoration. This is just a starter course. This is Ralph Brandt from the Fireside.